Welcome back to Getting Started with Linux. I'm your host, Daniel Lowrie, and we are back to take a look at, well, permissions. That's right. Joining me, as always, our good friend, Ross Brunson. Ross.
Hey.
Now, this is where the metal meets the meats, right? Because I've seen Linux permissions, and it basically looks like Sanskrit to me and most other people, and it can be extremely difficult to just decipher what the heck is going on. Hopefully you're going to be our savior today and elucidate these truths for us so that we can go forth and be good Linux users.
Now, they're just as difficult as you think.
Oh, crap.
They're really not. It's a very common misconception when people come, say, from the Windows world.
Yeah.
And the way that Windows handles permissions, let's say you're looking at a network share, and it'll have ACLs, access control lists, and there might be 15 different kinds of permissions under the covers.
Yeah.
Linux and Unix is pretty straightforward in that it has 3 permissions: read, write, and execute. We'll talk about these. We'll kind of show this to you in just a moment. We're actually going to switch over to our machine and show you where they often appear the most. And that would be, I've just done an ls-ld for directory to see the output here. And if you look, you've got the D for directory as the first character. That's the type. And then from there, we have 3 sets of 3. Now, I've gone through all kinds of different ways of trying to, the trifectas, the whatever, the permissions.
I always think of them as ZZ Top, right? Because there's 3 of them.
Right. There's only one of them doesn't have a beard, right?
Strangest thing in the world.
That's right. The guy named Beard.
The irony band.
Well, the reason why we talk about these and the reason why we look at these is because the permissions mixed with who you are and what group you're in is extremely important in how you get access to, or even if you get access to things.
Okay.
So when we look at this, we've got these 3 sets of read, write, execute, read, write, execute. If the bit is on, it's turned on, there's an R, W, or an X there. If it's not on, it's missing. That means that particular permission is missing from that, and you have decreased access to it. And we'll talk about that. But then remember, we have the user owner here, which happens to be root right now, and the group owner. Those 2 are very important. The rest of it, not so much, but this is the important stuff. So let's switch over to our slide deck here. And what we're going to do is we're going to go ahead and take a look at a graphic that I put together from long experience that will help us demystify this a little bit.
Okay.
So if you look here at the type, so the type is right there. That was that D character that we had. If it's a regular file, it's just going to have a dash. Effectively, there's nothing there. There's many different types. You might have C for character device, like a keyboard or a mouse. You might have B for block device, which would be something like a disk or something spinning or solid state, that kind of thing. You might have an L for a symlink, right? So it kind of tells you what the type of file is at the beginning of the file. When you look at the next set here, we've got the user here, group, and other. So UGO, UGO, kind of like the small Czechoslovakian car.
Yeah, great car, right?
Yeah, very good. Very inexpensive. Runs forever now. So the user, group, and other. Permissions are interesting because permissions actually come from this direction over here. And so when you try to access something on the system looks at who you are, who I'm signed in as, and it tries to match you up as the user. Are you the user or not? If I'm not, then I automatically go to group. Am I a member of primary or secondary of that group? And if I am, then I match. If I don't match the user or group, then I get stuck out here in other. And other is a very unprivileged area, typically, on a Linux system. Yeah. You might have read, you probably won't have execute, and you're certainly not likely to have write. So when we come across, the system says, please give me your credentials, and then it comes right here. If I'm the user, I stop. There is no such thing in this particular environment right here as effective permissions. Effective permissions is something that you might get if you're using an access control list somewhere. And we can use access control lists, file ACLs and directory ACLs in Linux, but not for standard permissions. If I'm not a member, if I'm not the user, then I'm automatically going to get matched against the group. And again, if I match the group, then I'm done. I never get the combination of user, group, and other, or any combination thereof.
So once it finds something that fits, it stops processing and just does whatever's there.
That's the access that you've got. You're absolutely done. Okay. So one of the other things that's very important for us to think about permissions. Wait a second here. Let's go back now to our system. And another thing that's really important about permissions is that when we look at permissions, with ls-l, that's one thing. There's another thing that we've already seen before in one of our others, and that is if I do stat of test, it'll actually give you a little bit more about the permissions. So if you look here, it'll give you what we call the octal or the numeric 0755. I want you to notice that there is apparently 4 sets of permissions as opposed to just 3 that we just talked about. That beginning one where the 0 is, that is what's known as the special bit. And we'll talk about that, but we need to understand the other ones first. So let's go ahead and switch over now to our slides again, and we're going to talk about directory and file permissions. And the reason we're talking about directory and file permissions separately is because they're different. So when you look at the read, write, and execute for a directory, it's important to understand what that actually means. So if you look here, when I have read on a directory, that means I can list out the directory's contents. So I could effectively run the ls command inside a directory. Does that mean I can see inside the files? No, definitely not. That security permissions are on a per object basis. So being able to have read on the directory file means I can cat out or list the directory file. I would actually have to have read on an individual file to see its contents. So the writing says that I can add or remove directory contents and or change the permissions on a file that's in that directory or another directory, let's say an object. So the reason that's important is because if I don't have write, all I can do is list the directory. If I only have write in the directory, can I see the inside of an object that's in the directory? Yes, based on the permissions of that object. Now, execute. This is one that has been driving people crazy for a long time. The concept of execute on a directory is totally different than the concept of execute on a file. Execute on a file means I can execute it, like a script or a binary. When we talk about execute on a directory, what it really means is that I can use that directory name in a path. So for example, I may have almost no writes on a particular, I might have read and execute on a directory. I can't do anything to that directory except use it as a path to get to another file. This shows up when you have somebody who has a public website that's part of their own home directory. So I might have a public_HTML directory. I'm going to have execute on the user's home directory so that I can kind of step across it and get into that other directory. So don't get lost with the execute permission on a directory. It simply means that you can use it as a stepping stone to, and for some strange reason, I always go back to that scene in the subway in Crocodile Dundee #1, where he's stepping across the tops of people's heads to get, right? That's exactly the sysadmin role. Here I am skipping across the top of the directories to get where I need to go. So,
excuse me, pardon me.
That's right. Whatever it is that actually helps you remember this. Okay? All right, so that's a directory's permissions. So now what we're going to do is we're going to talk about file permissions. So if we go back to our slide here, we see that a file's permissions is different because a directory is a container object and a file is effectively the last object. It's a directory is a branch. This is a leaf. Okay, you're not going anywhere else except for in this file. You're not using it as a directory. There's no way to traverse a file like you would have traversed a directory. The reason why this is important is because read on a file means I can see the contents of the file. So that actually matches with the directory permissions because you're looking in the directory file. Now you're looking into a regular file of some kind. Write says that I can edit the contents of it and change it. So when I say, I use VI or whatever, and I edit something and I save it, it actually allows me to save the changes. If I don't have access to that, I get that nasty thing that says, well, you're trying to write a buffer that's set to read or whatever. And usually most people will reboot at that point.
Reinstall.
Which, exactly. Which doesn't solve the problem at all. It makes it a lot worse. The last thing here is execute says that I can run this as a program. So I can actually treat this as an executable program of some kind, and it will read and execute the contents.
So the traditional idea that we might have as for what execute means.
Yeah, well, an actual execute means just run this thing as it is. So if it's a binary file, then I'm running the code that's in it. If it's an LSB executable, if it's a script file, I'm actually able to have the script interpreter, which would be bash, execute the file. Now, that doesn't mean that I can do it directly. I may have to do the // thing in front of it to get it to run, but otherwise that's what we're talking about. Okay? All right, so this is the concept of what we have as far as permissions go. We need to understand how to alter those permissions, And so let's cover now what it means when we use the two different modes of what we call the chmod command, chmod. Okay? All right, so chmod, let's go back to our system here, and let's talk about this great command called chmod. Chmod.
I like it. Makes me feel good.
Yes, so the three that we typically talk about is chmod, chmod, chown, known as chown, and chgrp, which almost nobody pronounces as chgrup.
I just assumed that was Klingon for something.
Well, it sounds like you're having a small stroke, is what it is. So I tend not to say chgrup.
I have aphasia.
Yeah, that's right, yes. So what I want to do is I want to show you chmod, and chmod or chmod is how you do one of two things. You set permissions or you alter permissions. Now, the difference between setting and altering, let's say that you have a very large directory, and in that directory, you need to make a couple of changes to permissions so that people get the right access to files.
Okay.
The very worst thing you can do is go in and to chmod and then 777 asterisk. You are now have set permissions on a large number of files, and you probably have caused all kinds of problems. So I always make the difference between the setting of a permission. So imagine when you use the 777 or the numeric format, you are setting a permission. When I want to change the permissions of a file using the numeric format, I'm effectively cold chiseling off the permissions and stamping new permissions on it. There's no such thing as altering it with the numeric format. If I want to alter it, what I would do is I would use the you can do four things. There's U, and then plus, or minus, or equals. And then you have read, or write, or execute. So you can get really kind of innovative with this. Let's say that I have a particular file, and I want to change the permissions. I want to alter the permissions of that file to match a particular thing. And really all I have to do to it is change it so that it has execute in every one of the three positions. Super simple. Chmod, and then I say A plus X, and then the file name. Like that.
Okay.
If I do that, it's going to set execute in the first, second, and third permission trios. Very simple.
Very easy.
Let's say, however, that I want to get a little more surgical about this. So remember, you're not cold chiseling it off and stamping it on. You're slicing and you're very...
It's scalpel time.
Yeah, right. You've got the scalpel out and you're doing exactly what you ought to do. You're making the least... It's like low-impact camping, okay? You're trying not to ruin the environment. It's like, rule number one, do not affect the local populace if you're landing on the planet.
No forest fires.
Exactly, right. So now let's talk about... I want to just change the other section to include the execute. Okay, so I would do O plus X, and it will add it. Even if it's already there, it'll attempt to add it. Let's say, however, that I've got a file that I want the user to have full access to. I want the group to have full access to, but I don't want anybody who's not a member of the user or group to have anything on. So I can use this interesting combination of, I'll say, and I'm setting effectively by altering. So watch this. So I would say UG equals RWX. So I would set it like that, and then I can go back over and I can say O equals, that's not O.
0.
O equals X. So what I was doing is I was saying set the first two to full and then make this one. So when I say equals, it means whatever I've got there. So if R and W were on at all, they're off. And X is the only thing that it is.
So what you're saying is basically that if I had other permissions on there, because you use that equal sign, those would be gone, and it equals whatever you put as far as permissions go.
That's correct. Now remember, because we've got the U, G, and O, whenever we alter permissions using chmod like this, the O says don't go anywhere else. Just go to the third set of permissions, and whatever they happen to be, it now equals just X.
Okay.
And that might be strictly for the use on a directory, that kind of thing, for traversing a directory.
Gotcha.
Okay. All right. So the other thing that we can do is let's go ahead and let's make a directory called perms test, following our format here.
Yes.
And in there, let's touch a file, and we'll call it file 1. Let's touch another file and call it file 2, file 21. That's good enough.
I like file 21.
All right, so what we do is we look at those. Now notice that I've got read-write, read, and read on these two files. This comes from this funny thing called a UMask. So a UMask, you can determine what your UMask is. UMask is what is subtracted from the default permissions that are set on a file or a directory. Let's create one directory. We'll call it mkdir directory. And let's do an ls-l and see the difference in the permissions. What's the difference in the permissions between the directory and the files? Directory makes use of execute. Why? Because you need to be able to traverse that directory and use it in a path. So this should tell you if the UMask is subtracted from the default permissions, then we need to know the default permissions.
It seems logical.
Okay, so here, let me give you a quick view of the default permissions. For a directory, the default permissions equals 777 because of that execute. Right, so read, write, execute. The default permissions for a directory is 777, and if I take 022 and subtract it from 777, I get what?
055 or 755?
Right,
yeah.
Which is exactly what we saw on the directory itself.
Awesome.
Now, if we'll, I'm trying to make it so that we can see this here, a file's default permissions are 666. So what I like to say, just for rememberability's sake, is that the file permissions, default permissions, is the number of the beast. And right next door are directory permissions, the neighbor of the beast. Okay? So just remember that when you have a UMask, it is subtracted from the default permissions that are there.
Gotcha.
So a 666 minus 022 is a 644. And so when we do that ls minus l of everything that's in the directory, you'll see that that matches exactly what's here. Now, there's a question that often occurs, and people will say, now wait a minute, I have seen a 027 UMask. How in the world do you subtract 7 from a 6 on a file? What do you get, a -1? No. Files only go to zero, and that's everything goes to 0, and so that's how the UMask is able to handle both a directory and a file at the same time.
Oh, that makes sense.
Okay, so with that little tip, let's clear things and let's do a quick ls-l and let's change the permissions using the numeric format. Okay. So I'll say chmod 777 and file 21. Now what this does is this goes, and regardless of what file 21 had before, slam, cold chisels the permissions off, stamps them on there, game over. There's no alteration to this. These permissions have been set. If you were wondering what they were before, well, you better look at a backup because you're done, okay? You can't just easily go back. What you can do is hope that you have in the screen buffer an ls-l output. So you'll notice that, I should say, for the sake of elegance, most system administrators or operators will do an ls-l of the object they're about to alter in the faint hope that they might be able to get back. So now that we've changed the permissions on file 21 to be 777, you see that that's reflected right here in the read, write, execute, read, write, execute, read, write, execute. Now, that is the setting of permissions, the cold chiseling of permissions onto something. Now let's do an alteration. And so what we'll use is the same command, chmod, and now we can have, let's do a full-featured chmod alteration command. That's right. Let's as the fellow said in Office Space, I appreciate the full catalog of Michael Bolton's music.
Right.
That's right. Let's appreciate the full catalog of chmod's wonderful utility here. So let's say the user equals, or let's say user, let's do user equals RW, comma, then G would be a plus WX, and then, comma, and then O equals X. So this is file 1. So what's going to happen is it's going to look at the current permissions on file 1. It's going to make sure, because of that equals sign, that the only permissions in the first trio are read and write. So equals is effectively setting the permissions for that trio. However, I can set per trio with this mode as opposed to setting them all at once with the other one. then G plus WX, whatever's in there, is going to make sure that write and execute are on this. Doesn't matter what's in R, doesn't matter, it's going to leave it alone because I didn't specify that. It's just going to add write and execute. And then on the last one, it's going to make sure that this only has execute for the other. All right, let's see if it executes. And it does.
No errors.
Right, well, no apparent errors. And so now if you look at that, file 1 has exactly what we said. We said, make sure that this first one is read and write only, and that is true. The next one, whatever's there, make sure you add write and execute. So it did, it left the R alone. And then sure enough, that last one is now set to just execute. Some people will ask at this particular point, how do you know, we just talked about an error, how do you know if an error occurred? Sometimes there's no error output on the screen. What you can do is if you execute something and your spider sense says, that doesn't seem quite right. I didn't see output, but something happened and I'm not sure what it is. Or you accidentally execute something and it works or apparently works. What you can do is you can say echo $question mark. $question mark will come back with the exit code. Here's how to remember the exit codes. A 0 means that everything is okay. Any other digit means things didn't work. And so the joke being is that the system is letting you know with a single digit things didn't work.
Aha.
We'll stop right there.
I'll see what you did.
1 or 127 or any number other than 0, and you know that things didn't work properly. So remember, echo $question mark will help you with that.
Well, Ross, thank you so much for making this a little bit easier for us. You're definitely getting me some buy-in on this Linux thing. Hopefully, you good folks out there aren't as scared of it either. And now we can actually start using Linux. And it's lovely. It's a great thing. That being said, we're out of time for this episode. We're going to have to come back and look at special permissions in the next one. Until then, we'll see you next time.